we'll go on and get started. So we finished talking about this yesterday, and again, set builder notation is helpful when trying to write out a set or a group of numbers I'm going to say is too tedious than we actually want to do, or it's not physically possible. We'll use set builder notation. Now the next thing we're going to do is we'll do these two here, and probably that'll be enough examples to look at. We're not going to need to see a whole bunch. Because what we're going to do here is we're going to sketch the graph of each set of numbers. So if we look at the first one here, we have the set of all real numbers x such that 2 is less than x is less than or equal to 5. So what are we talking about? We're talking about all the numbers between 2 and 5 that include 5, yes? So if we were to graph this on a number line, well, we would put a circle at 2 and a circle at 5. We'd have points at both of those spots. Well, what would we need to do next? Y'all remember? Because if the circles are open, it means they are what? Included or not? Not included. Enclosed means? So do I need to shade either one of these in? Is 2 or 5 one of those included? 5 because it is equal to. So we fill that in because it is equal to. Now because it is an and statement, and we know it's an and statement because x is in the middle. 2 is less than x, so x is greater than 2, and x is less than or equal to 5. So that's all the points in the middle. It's all the points in the middle. And most all of our and statements, when we have number, inequality sign, x, inequality sign, number, we're shading in the middle. X is in the middle, shade in the middle. Any other questions on the letter A on the first example of the day? Okay. So look at B. For all real numbers x, such that x is less than or equal to 0, or x is greater than 4. So here we're going to have two spots. We're going to have one at 0 and one at 4. Because those are our 2 points. Will one of these be opened? Are they both going to be open? Both closed? One open? One closed? 0 should be closed because it is equal to. And the 4 will be open because it is not equal to it. So let's take each one of these steps, or each one of these inequalities individually, because it is an or statement. So here, x is less than or equal to 0. So at 0, we're going to shade to the left or to the right. Left. And then we would go to the right for 4 because it's talking about it being greater than 4. And that's it. That's all we have to do for this here. Now, because it is an or statement, we can graph both of them at the same time because or either one works. Or it could be both. So with or, we can go on and graph it. And we won't have to worry too much about this because we won't be dealing with this and that, 2 and statements where we have to worry about overlap and what is included and what would not be included. So we'll have to worry about that at a later date. So let's look at this one here. Sketch the graph of the set of numbers for this here. So the set of all real numbers x such that x is less than -2 or x is greater than 0. So we have 2 spots at -2 and 0. So which one would we fill in? Neither, because neither one of them is equal. If they're equal, then we fill it in. If it's not equal, we do not. So for -2, which way are we going to shade? To the left, because it says x is less than, smaller than -2. And for 0, we shade to the right. And that is it. Any questions on any of these here? Do we remember inequalities pretty well? Being able to graph them? Yes. Okay. Either one of these two that y'all want to look at before we move on. One of them in particular, or are we good to just, do you guys feel comfortable enough to move on from graphing inequalities? Yes? Y'all don't need to see another one? Okay. We good, Trenton? Or do you want to see one more? We can do one more. There's nothing wrong with doing that. Either one of these in particular? Okay. So we can look at number 4. For all real numbers x, such that -6 is less than x is less than or equal to -2. Now, if you notice on this one here, there are no numbers on the line itself. Now, some would want you to start off with 0 and then kind of make it adjust accordingly so we know scale perspective. We can do 2 spots. I'm not going to make you put a 0 and kind of scale it because, well, if we know the 2 endpoints, we know where 0 should be. They mainly use that as a way to kind of make sure that the smaller numbers stay on the left, the bigger numbers stay on the right. Our smaller number is -6. Our bigger number is -2. That's all I'm going to ask for doing numbers and labeling it. Because we have our 2 points, -6, 2. We don't need anything else. We should understand how the number line is set up. And we'll have our 2 circles. So our -2 is closed because it is equal to. And since x is in the middle, we shade in the middle. And that is it. Any questions on 4 or questions about how to do number 5? So I'll go on and just show you, because if we did 5, we'd have 0 and 10, open, close on both. X is less than or equal to 0, less than. X is greater than 10. And it would just be this here. We ready for the next thing? Okay. So we're going to start using set builder notation. So the next few, we're going to use set builder notation for them. Now, once we get past that, some of them we may or may not. Because when we start talking about some sets, we'll get there, it'll make sense. So the first one we're looking at here is the set of all integers greater than 5. We want to write this in set builder notation. Well, set builder notation, as we saw yesterday, starts off with a brace, x. So no matter what the number types are, this is how it's going to start. Now, what kind of numbers are we talking about? Okay. So the set of all real, well, it's not all real numbers. X is an integer. Because I think the book likes it outside. I might be, because I like doing it this way. we doing? Yep. I think I'm wrong. So I think we'll do this here for the set of all real numbers x such that x is a what? X is an element of the integers, and x is greater than 5. I'll look back into that a little bit more. We'll stay with this here, because I feel like I might be right with the way we were doing it, but I just want to lean on the other side. But that's it. That's all we have to write. All values of x in the... Yeah, I think it's fine, but we'll stick with this for now. I'll look it up tonight and figure that out and let y'all know. I'll probably know by the end of the next hour. Any questions on this here? So we look at this next one, if there are no questions. For all values of x, such that what? What kind of numbers are we dealing with here? Are we dealing with real numbers, natural numbers, whole numbers, integers? What? Yeah, well, actually all real numbers, because we're talking about an interval. Because anytime we talk about interval notation, because we're talking about negative infinity to 1, we're talking about all the numbers between it. So this would be all real numbers. So for this here, we'd have the set of all real numbers, x, such that what? We have these two statements, yes? But we can't just put those down. We actually have to have them as an inequality for both of them. So for the first one here, negative 1 to 1. So this would be x is what? Less than negative 1, because negative 1 to infinity, or negative infinity, comma, negative 1, is saying we're talking about all the numbers less than negative 1. Or, what is our other one going to be? X is greater than negative 1. So we have both ends. Now this here, we could actually write it in a different way because, well, this here, if we were to graph it, you don't have to graph it, because we'd have negative 1, open, and we'd shade everything that way. That would be the first statement. The other statement, well, negative 1, and we shade everything the other direction, yes? So what's the only thing not included? Negative 1. So what we could say is, well, this is saying for all real numbers x, so everything, x cannot be what? Negative 1. Because that's the only thing x cannot be. So we would have this here. Any questions on this here, anything we've done so far? Okay, sorry, that was bugging me. But the reason I was doing that, I wanted to check that real quick to make sure I wasn't telling you the wrong thing. It actually does work. So, going back up here, you don't have to rewrite it, okay? This here, x, is an element of the integer such that x is greater than 5 is a correct way to write it. This is what our textbooks was saying is wanting to use. The other way is correct also. So let's look at these here. So we're not going to use the for all or the backwards of the existence, above and beyond. So let's look at this here. For all values of x, because again, we have inequalities, we have intervals, so we're talking about inequalities. So that means we're talking about real numbers. That's nice. When we're talking about real numbers, we're not having to specify, understood, to be real numbers. But these two parts here, this one and this one, we will have to rewrite them as an inequality. We can't just leave them as interval notation. The use of interval notation in set builder notation isn't preferred. So we need to actually rewrite these as inequalities. So negative infinity to negative 1, so we're talking about all the values what? Less than negative 1. So we're saying x is less than or equal to negative 1 because we have a bracket. Bracket means equal to, parentheses means not. Or what? X is greater than 1. And that's it. Now, on the previous one where we were able to rewrite it as x is not equal to a number, we can't do that here because I mean, we technically probably could. Actually, we could, but it would just be a little bit trickier in the notation. Because most of this here is all about the notation and how we write it. Just like with English, it's all about translating what you are trying to say or what you're trying to talk about. And I think I've gone off on the tangents for over the top already. I think y'all are done with the upper level stuff. And when I say upper level, I mean the fancy stuff. I paused the video to show you. Because I think y'all are happy with this here, yes? Yep, okay. Let's look at the other one. The set of all integers except negative 4. So what value can it not be? Negative 4. Or any decimals, but we're not concerned about that. So here we would set it up as bracket, or yeah, brace, x what? Our funky E element or group. X is in the group of, or X has an element of what? The integers. And our symbol for integers is our Z with a bar, an extra line, and then we'll throw the bar down. So, we could do this in different ways, but really I think the way that y'all would like is that we say X is not equal to negative 4. It can be anything else, it just cannot be negative 4. It can be, well, it can be any other integer except for negative 4. Questions on this here? All right. So we have 1, 2, 3 more problems we're going to look at, and then we are done for today. That's all we're going to cover. There are more notes, and I'll talk about them, but I don't find them interesting or relevant for how we do it. It's weird. This is the first one we're going to look at. Writing it writing subsets in set notation, writing this in set builder or set notation. So would it be difficult to write out the whole numbers 50 through 54? Because what would those be? Well, 50 and 51, 52, 53, 54, yes? Wait, that's 5 numbers. I could do that. Why not just write it as a set? Because if it's easy enough to just go brace 50, 51, 52, 53, 54, we're done. That's it. We listed them. Because if you're able to list them out, we'll list them out in a set. Because if I wanted to use set notation, well, it'd be x is an element of the whole numbers such that 50 is less than or equal to x is less than or equal to 54. And really, mathematically, I don't like using whole numbers. I would just say integers. Because the only real difference between integers and whole numbers or integers or in whole numbers and natural numbers is it adds is 0. Natural numbers does not have 0. Integers includes negatives. Well, whole numbers, integers. Whole numbers does not have negatives, yes? Is 50 through 54 have any negative numbers? Am I essentially saying the same thing? Yeah. And whenever you make those switches, it's just you have to make sure. So if it's talking about whole numbers, we don't include negatives. So if it had just been less than 50, well, okay, we've got to adjust and say it's greater than 0. Questions on any of this here? The real numbers, 0 through 4. So we can list those out, yes? So our first one would be 0. What would the next number be? Almost, because it's real numbers, right? So the next number is 0.1 or 0.00000001, then 0.00002, 003, because we have all the decimal numbers and all the irrational numbers, everything between 0 and 1, not including between 1 and 2, 2 and 3, and 3 and 4. So is it feasible to actually write out all the numbers between 0 and 4? No. So this is when we would go to set builder notation, because it's not feasible for us to actually write them all out. So we're going to use the set builder notation. And since we're using all real numbers, we just have brace x bar for all real numbers x such that what? 0 is less than or equal to x, less than or equal to 4. Since we have 2 endpoints and everything in the middle, we use an AND statement. I went back and forth with this morning. Earlier I was just using less than and greater than. It actually works out it is equal to, because 0 through 4, talking about the endpoints. Now, on a test, something like this here, if you disagree with how I mark it, talk with me. If you convince me, okay, I can see that point, not I believe you, but if I can see how you came about it that way, I will give you the points. You won't have to full on convince me of it, but if I can at least see, okay, that makes sense, that kind of works, I understand with that terminology, I'll give you the points. If it doesn't, I'll tell you, and we'll move on. But again, if you talk with me, I'll work with you. The last one we'll look at, the integers, negative 1,000 through, not 1,000, negative 100 through 100. Could we write all these out? Yes. Could you pay me $100 to write all those out? Maybe. Because again, that just comes down to what do you value your time? What's your time worth? I'm going to use set builder because writing 201 numbers is a little excessive. So we're going to say x, what? Are we talking about real numbers? No, we're talking about what? X is an element of the integers, such that negative 100 is less than or equal to X is less than or equal to 100. And that's it. That's all we have to do, because we're just writing the negative 100 through 100 as an inequality, because we're talking about those two as the endpoint and everything in the middle. And that is it. Any questions on this here? Okay. I will tell you, I'm just going to talk you guys through this. I'm not going to be throwing ones like this up here because I feel it's a little weird and it doesn't really show much. Because one thing, prime numbers, we do not know the last prime number. It is under the common knowledge or common sense, or kind of however you want to phrase it, that there's a ton of prime numbers. It has not been proven yet, because we're still finding prime numbers, so we're not sure. So the mathematics community is not 100% certain if there will be eventually a point where we get such big numbers that there will always be at least one set of factors, two numbers that multiply together to give us that number, if that will reach it, or if it will actually be the case that there will be prime numbers no matter how far we go out. The current theorem that's going about it, they haven't proved it yet, I believe, is the Riemann's Hypothesis. If you're able to prove it, you get an award. They give you an award for it and $1 million. It's one of the $1 million prizes. There are, I believe it's either 8 or 10 of them. Only one's been proven. And the guy who did prove it, they gave him the prize, and then he told him, I don't want the $1 million. Because he was, for one, doing it because he enjoyed doing it, and two, he was working off someone else's work. Someone else had started it, and he picked it up and finished it. So he didn't feel like he deserved it. So, to each his own. Now, with this here, really the way we would end up doing this, we're saying the set of all X is a whole number, such that, y'all ready for this? What are we talking about? It is prime, right? X is a I don't. You're just literally copying down what it says. X is prime number. For like these here, for all values of X, X is an integer. For all values of X, X is a whole number. I mean, that's not really just writing stuff. But that is it. That is all we are doing today. And this here is your homework on page 7, 5 through 14, 17 through 24, 26, and 27.